Good morning, everyone. So today we are going to talk about the 7 testing principles, and we'll discuss each and every testing principle one by one. Okay, so let's start. Okay, so the first principle, testing principle, says that testing shows the presence of defects, not their absence. Okay, so there is nothing called a bug-free software. Okay, and there is no way we can prove that whether the system have any bug, or you can say the defects or not. Okay, we cannot prove it. There is a possibility that maybe few defects will be only reproducible with a certain number of test data, with a certain test data, you can say, or maybe some specific circumstances that should be the maybe the user interaction with the system, or some or maybe you can say some depend on some environment. Okay, or maybe networks. Okay, so we so what we can do, so if a test if we cannot prove that any system have a defects or not, how will come to know whether whatever the testing we are doing that is enough or not? So there is only way to prove to conclude that we need to design as many as tests possible. Okay, and we need to find as much as we can, that definitely depend on your if risk based testing if you are doing, and that depend on your time and budgets, right? And definitely depend number of test cases you have written. If you have executed all of the test cases, it means that yes, you have covered as much as, and if your coverage you have done as a very good number of coverage, you have done 100% coverage you have done, or 95, that it means that you have reduced the risk of the defects, or you have reduced the risk of failures. Okay, so the testing reduces the probability of undiscovered defects, okay, remaining in the software. But even if no defects are found, testing is not a proof of correctness. Okay, so this is all about this, the first principle. Okay, now the next principle is the exhaustive testing is impossible. What does it mean actually? Okay, so it means that if you are testing any applications, there will be a lot of permutation and combinations, right? So if there is a lot of permutation and combination, do you think that we can test any system with all the permutation and combinations? Is it possible, or is it a feasible way? No, absolutely not. Take example of if any test box is there, right? Which is taking input of age between 10 to 50, right? And we need to pass an integer value. Okay, so you can say if that is only accepting an integer value, so what is the combinations we can pass? The integer range that is start from the minus 32,000 something from to plus 32, right? So if we are testing with all the combination, and around it's a 65,000 something value we need to enter to test it, the system complete. Okay, whether the system is accepting an integer value or not. So what I want to say, that whether it's not a feasible at all to testing one single test box with the 65,000 of test data. Okay, that also maybe we have to check with the other negative scenarios, like whether it's accepting alphanumeric or character or float, double, all those things, right? So it's not at all possible. What I mean to say, the exhaustive testing is impossible. So we need to use some test design techniques. Okay, and there are some test design techniques are available for the white box as well as for the black box testing. So in black box we have for such type of scenario we have equivalence partitioning, and we have a boundary value analysis. Okay, some other techniques is also available, like use case and then state transitions. Okay, so such test design techniques are available, which will help us to design our the test cases and test data. Okay, so I hope this second principle will be clear to you, all of you. Okay, now come to the third principle. The third principle says that early testing saves time and money. Okay, so So if any bug, right, if it is discovered in the requirement phase, okay, yeah, during the requirement gathering time, the cost of fixing this bug is very cheap. But just assume that we some any case we are not able to detect such issues, okay, that requirement bugs whatever we have found, we are not able to trace at the requirement gathering time, and we are finding at a, you can say, maybe on the when you are doing that system testing, or when the system has delivered to the customer, okay, at that time the customer is finding this failure. Okay, then what will happen actually? Again, just try to recall the software development phase, the requirement, right, the design phase, then development is there, testing is there, deployment. Again it will go start from the scratch, from the starting points, okay, and again all those it will go through all the phases. So now think about it, how much time it is taking, right? And it will involve all the resources we will have, okay, and again it's the same repetitive task we are doing. So as early we'll find the issues, okay, it will be more cost effective, okay, and if you find the late, then you have to pay more, okay. So what I mean to say that we need to start our testings as early as possible. So definitely, so if any project start from the scratch, right, just start from the requirement gathering, okay. So from that time only the testing team, or even you can say the whole development team, should start a testing. And now you can say how we can start a testing, because there is no code is developed, okay, there is no system is developed to do that any testing, okay. So we have a so that time, so when the requirement gathering is going on, when you have only specification document only you have, so what we can do, we can start a static testing, where what we do all the review of the document, okay, the formal review we do, inspections, walkthrough, all type of static testing we do. We'll verify whether requirement is valid or not, okay. If any ambiguity is there, so you can resolve it. If any design issue is there, so we can go through all the user stories, okay. So, and if you have any doubts, we can clarify that time only, instead of doing that thing into the last times in the design, or maybe if you found that application is not at all not at all feasible for the end user, okay. So take an example actually. Any software is you can say it's a bug free, or it's a valid software. It's not only if it's don't have any bugs, right? That also depend on that, whether that software or product whatever you have developed, whether it's giving a benefit or giving advantage to the end user or not, whether user is able to use it or not, okay. So if the user is not able to use it, he's not at all using, then there is no even though you don't have any bugs in your systems, that software is completely you can say there is no use of that system, right, the application of product, okay. So that's why that's why this third testing principle emphasis on that we should start our testing as soon as possible, okay. The fourth testing principle is a defect cluster together, okay. So so I think most of you may be aware about this the Pareto 80-20 principles, right? Means most of the problems, means 80% of problems lie into the 20% of issues, and your 20% of right, so 80% of issues will fall into the 20% of, you can, so on the, you can say, the module. So in testing context I'm telling you, so you have a 80% of bugs will be found into the 20% of the modules, okay, and 20% of the bugs will find into the 80% of modules, okay. So likewise we need to identify which are the modules, okay, are very crucial for the user point of view or the application point of view, that we need to identify. We need to do the risk based testing. We need to identify those such modules, okay, and we need to focus more, we need to put lot of effort onto those modules, because there are chances that we will we will found more bugs on those modules only. Okay, instead of checking other those rest 80% of modules. Okay, so this is all about the defect cluster together. Okay, the fourth testing principle is the beware of the pesticide paradox. Okay, sorry, this typo. So the pesticide paradox in the sense, so we know that, right, for the crop we use the pesticides, right? So what this pesticide does, this the pesticide obviously it's kill the insects. Okay, but after sometimes what we see that using the same pesticides again and again on those insects, right, they develop the immune system such a way that so further they will not get killed with the same pesticide if you are using. Okay, so what we do, then we change the pesticides, and when we change the pesticides, then again those this pesticides, the new pesticides will able to kill those insects. Okay, and this process will continue. Okay, in the same manner, right, in our testing. Okay, so when we develop any test cases, right, okay, and after sometimes we'll observe that we are not able to get any new bugs, we are not finding any new bugs, then what we should do actually. Okay, so so if you are using same test over and over again, eventually the same test set of tests will no longer find any new defects. Test cases need to be regularly reviewed and revised. So how we have to regularly do the review. So in terms of just change test data, pass some different test data, and if you feel some additional test cases are required to be just add a new test cases, or if any test cases need to be modified, do it. Okay, so this is fifth testing principle. Okay, now the sixth one is testing is a context dependent. What does it mean actually? Okay, so if you are doing so so if you are doing the testing, right, we do the testing of different type of applications which belongs to different domain. Okay, we do testing each and every field. It's not only software only we do the testing, we do in the manufacturing, we do in the chemical industries, everywhere testing is there, right? Because without testing, how you can launch any product to the end user, right? So we have to do the testing, whether it's a software industry or it's a manufacturing industry or it's a auto industries or wherever it is. Okay, so testing, we cannot do the testing the same manner what we do into the software industry or what we do into the manufacturing industry. Even in the software industry also, if you see the different type of application we'll have, like we'll have e-commerce based applications, we have this aerodynamics applications we'll have a healthcare applications. Okay, aero industries applications will have. Okay, so e-commerce industry, we do that, whatever the testing we do, it's a different way. Okay, the healthcare industries, all the applications should compliance with the HL7 and HIPAA should be compliance. The industry which deal with all the airlines, right, where there is no chance of any failure or bugs because it will cause a human life. Okay, there will have some different industry standards where our application should compliance with that standards. Okay, so definitely the way of testing we do, it will be completely different to each and every you can say the domain or the industries. Okay, so it's completely depend on the in which industries we are or which application we are testing. Okay, so the testing will be different. So this is all about the context dependent. Okay, the last testing concept is the absence of error is a fallacy. What does it means that actually? So this is a mistaken beliefs, you can say, that you can, okay, so means if you understand this software with no known error is not necessarily ready to be shipped. Does the application under test fulfill the user needs or not? Okay, so absence of error means if you think, okay, your software, right, there is no issues, you didn't found any bugs, means it is a completely you can say that this software is completely foolproof. There is no, because I didn't found any bugs. So now this is ready for launch, and it is completely viable product, and the user will use it. No, until unless it is not at all compliant with your user requirements. And last also, if user is not happy, user is not using, not able to use it, there is no point. Even though there is no bugs, actually there is no point of your software. Okay, and it's not going to add any value. So your whatever you have developed, right, there is no purpose, there is no use of that product or software. Okay, so this is the last testing concept. Hope the all testing concept will be clear to you. So if you have any doubt, please put in your comment. I will clarify the doubts. As of now, I'm closing this sessions. Yeah, thank you very much.